Hello students, I hope that now you are all acquainted with the different ranges of the microwave frequencies, the different microwave bands, their applications and their actual benefits and the shortcomings. Now as a part of the second unit, we're going to talk about very important thing that we call it as a transmission line. So the importance of transmission lines and the waveguide is well known in the various fields of the engineering. For an electrical and electronics engineer, it is necessary to know the basics of the theory and the practical implications of this transmission line theory at a high frequency. So as a second module of this first unit, we're going to start a new topic called transmission line theory. Now, have you ever thought like why we use different sort of medium for transmission of different frequency signals? Why can't we use a single medium for transmission of all sort of signals? Why parameters involved in designing and analysis of these transmission lines are very complex? Which parameters are actually responsible for analysis of these transmission lines? What are the different types of the transmission lines? If I want to make a transition device from, let's say, guided to the unguided medium, then how can I do it? We try to figure out the answers of all such questions in this particular topic. So we're going to start our topic with the introduction to the transmission line. Then we're going to see the different sort of transmission line that is available or that is actually using by any RF engineers. Then we're going to see the general representation of any sort of transmission line which we are going to use for our mathematical analysis. Then we're going to talk like what are the low frequency and high frequency effects. Then we're going to take up a very important topic which we call it as a transit time effect. Then we're going to talk like what are the lump circuit elements and what are the distributed circuit elements. And in the last, we're going to end up the lecture with the different analysis of the circuit, distributed circuit analysis. Now, in order to understand this topic better, I insist every student to brush up their fundamentals of circuit theory and Maxwell's equations. I suggest to go through the concept once again from Elements of Electromagnetics by Matthew Osadiku. Specifically, you should know how to solve complex number operations using a scientific calculator. I also insist every student to attend every lecture with one plain paper and calculator, as we are going to solve various numericals with the progress of this course. This topic is very interesting as you could verify every analytical relations with graphical approach also, which we call it as a Smith chart. So don't miss the lecture and be with me with the whole of the content. Hope to see you all in my next class. Thank you.